Hi everyone, we're going to talk about the mean value theorem in this video. Alright, so there's a picture here to help us understand what this theorem tells us. Let me read the paragraph first. The mean value theorem guarantees that there is a point where the tangent line is parallel to the secant line that joins points A and B. So you can see here in this picture, we have points A and B on the blue curve. So your points on our function. And then yellow here is the secant line connecting the two. The mean value theorem says as long as f, your curve, is continuous and differentiable from A to B, outside of that we don't care, but from A to B, continuous and differentiable, then there exists a point somewhere between A and B, in this case it's C, where the tangent line at C has the same slope as the secant line. So you can see here, this is the slope of the secant line, call it M sec. And then we have the slope of the tangent line. So slope of the tangent line. So the mean value theorem says, as long as f is continuous from A to B, then there is a point between A and B so that the slope of the tangent line is equal to the slope of the secant line. And in the formula, that would be this here. It says the slope of the secant line, that's this fraction, is equal to the slope of the tangent line, which you already know is the derivative. Now, it doesn't say there's only one, it says there's at least one point where this occurs. Sometimes when you work these problems out, you could find more than one point where the tangent line is parallel or equal to the same slope as the secant line. So let me show you what kind of problems you'll be asked to do. Example, find the value or values, remember there could be more than one value of C, that satisfy this equation in the conclusion of the mean value theorem for the following function and interval. Now, technically, before we start this formula, we should make sure the mean value theorem applies. So, the mean value theorem apply? Question mark. Well, it says f has to be continuous. Well, this function is continuous except at x equals 0. At x equals 0, we have a vertical asymptote. But that's outside of this interval. So, in our interval, we are continuous. At 0, there's a problem, but 0 is not part of our interval. Is f differentiable? How do you check and see if a function is differentiable? You have to take the derivative. See if the derivative exists at all points in your interval. So let's work out the derivative here. So the first term's okay. 9x becomes a 9. This 9 over x, we should probably do some algebra. Let's rewrite it. This is really 9x to the negative 1. So the derivative would be negative 9x to the negative 2. If we rewrite that, 9 minus 9 over x squared. Is this derivative defined over our interval? The only point where this derivative would have an issue is when it's undefined. When this denominator equals 0, the f prime is undefined. But that is not in our interval. So f is differentiable on our interval. Not everywhere, but on our interval, we're good. So the mean value theorem does apply. Now we can continue with the theorem. So that means if we solve this problem, we should find a C in this interval that satisfies this problem. All right, so let's do this. On the right, f prime of C, we actually already found f prime. So all we have to do is plug in C. On the left side, we got to find the slope of the secant line. So let's work that out. So A and B are your interval values, so 1/2 and 2. So we're going to find f of 1/2. Let's see, that would be 9 times 1/2 plus 9 over 1/2. All right, work that out, and that'd be 9 over 2. And when you divide here by a fraction, you flip it over and multiply. So it's actually plus 18. And f of 2, f of b, that'd be 9 times 2 plus 9 over 2, or 18 plus 9 over 2. Wait a second, those two are the same values. All right, so let's do our secant line then. The slope of the secant, the formula says f of b, which is our 2, minus f of a, that's our 1/2, all divided by b minus a. If we plug in our information here, f of 2 was 18 plus 9 over 2. I could put that into a decimal if I wanted, or combine the fractions, but watch, they're the same values. Because they're the same values, what's going to happen? We don't care about the denominator. It's not 0. We do care about that. But the numerator is 0, so this whole thing is 0. So we have the slope of the secant. We have the slope of the tangent. According to mean value theorem, if we set these equal to each other, we should be able to find a point that satisfies the equation. So we're going to take our slope of our secant, set it equal to the slope of the slope of the tangent line, set it equal to the slope of the secant, and solve. If we find an x, then we found the point that the mean value theorem guaranteed us to find. All right, let's bring the negative term around. So leave the 9, bring the 9x over x squared around. We can multiply by x squared. So 9x squared equals 9. We can divide by 9. So x squared equals 1. So we found x equals plus or minus 1. Be sure, though, you only give the answer in your interval. So in our interval, we have just x equals positive 1. So this is in the interval from 1/2 to 2. Okay? So that's how the mean value theorem problem would work. We found out the mean value theorem applied, so we knew we were going to get an answer, and we found our answer. If the mean value theorem does not apply, that doesn't mean there's not an answer. That just means that we don't have the conditions met to where we can guarantee that there's an answer. All right, let's try this one. Does the function satisfy the hypotheses of the mean value theorem? Remember, the mean value theorem requires continuous and differentiable in our interval. So, is f continuous? Well, this is a root problem, or a root function. If you were to graph this, feel free, it's an interesting graph. This is in fact continuous. There's no points where there's a break or a gap or a jump. On the other hand, to find out if it's differentiable, you can take the derivative. So what's the derivative? Power rule, so 8 over 9, x to the negative 1 over 9. So 8 over 9, x to the 1 over 9. All right, this is the derivative. Is the derivative defined at all points in this interval? Well, look at your function. You have a denominator. If x equals 0, then f prime is undefined. What does that mean about the condition? F is not differentiable at x equals 0, which is inside of our domain, our interval we're interested in. So the answer is no, we don't satisfy that requirement. So we were continuous but not differentiable, so mean value theorem does not apply. Okay? So that's the mean value theorem for you. We'll talk about it a little bit more in the next video where we do an application, where we talk about velocity and such. So make sure you study hard, do your homework, and I'll see you in the next video.